In this video, we are going to learn about vapor pressure and its effect such as cavitation. Today, we will discuss vapor pressure and cavitation. So, vapor pressure is important phenomena. We will understand why it is very important. But now, let us start with what vapor pressure actually is. So, the vapor pressure is the pressure at which the liquid phase and the vapor phase of a material will be in thermal equilibrium. So, this is very important part, and see what happens. So, in this example, I have shown you the interface. So, this is basically the interface. Which interface? Water air interface. So above this is air and below this is water, which can be any other liquid also if you want to use, but I have taken example for water. And this is our interface. This is the interface. So actually what happens here, the exchange of molecules, it keeps on taking place at the liquid air interface. Why? Because the liquid molecules, the water molecules at the surface, they escapes in form of vapor, in form of vapor to the atmosphere. And when they escapes and they reach to atmosphere, then what happens? They exert a partial pressure. They exert a partial pressure. But remember, what is the basic difference between vapor pressure and partial pressure? So remember, do not get confused. Definitely, they are the different terms. Partial pressure is defined as the pressure of a gas or vapor in a mixture with other gases. Remember, this is the pressure of a gas or vapor in a mixture with other gases. Remember, this is pressure exerted in a mixture with other gases. This is important. While when we talk about vapor pressure, so here important term is that liquid phase and vapor phase, they must be in equilibrium. We are talking about the pressure between this liquid phase and vapor phase. But when it comes to partial pressure, then we are interested in the pressure with other gases. Remember, this is the basic difference. Now, this can also be defined as this can also be defined as the vapor pressure of a pure substance is defined as the pressure exerted by its vapor phase equilibrium with its liquid at a given temperature. So this can also called saturation pressure. Now saturation pressure and vapor pressure, they both are same. So do not get confused with them. Now remember, the vapor pressure is different, partial pressure is different. But when partial pressure becomes equal to this saturation pressure, then this vaporization or bubble formation mechanism will start. When this partial pressure becomes equal to saturation pressure, which is equals to vapor pressure, so then what will happen? Then bubble formation will start, and we don't want it actually. This is undesired for us, right? So what happens actually, vapor pressure increases with temperature. Boiling occurs when external absolute pressure exerted upon the liquid and vapor pressure becomes equal. So this is the same thing, and you might have seen, like whenever we are on ground. So here we know that at 100 degrees centigrade water will boil. But what happens if we keep on going up? So at very great height, such as like we talk about mountains. Suppose we are on a mountain, and here if we want to start boil, so boil will start boiling, water will start boiling at a temperature much less than 100 degree centigrade. So you should keep this also in mind, that the vapor pressure, it will be affected by temperature and pressure both. While the vapor pressure increases with temperature, while the vapor pressure increases with temperature, it decreases with pressure. Now, when this height will keep on increasing from here to here, height will increase. So we know that the pressure value will be decreased. So pressure we have not studied yet, but we know that as we go up, pressure keeps on decreasing. Pressure keeps on decreasing. As we come down, pressure keeps on increasing. So here pressure is more. Suppose this is P2, this is P1. So we can easily say that P2 is greater than P1. So at lesser pressure, the water will start boiling at lesser temperature. So that is the reason you might have heard that suppose any food that will be cooked on mountain, so you know that it will take a little longer than it would have taken at the ground. So that is the basic difference. If ground it takes 20 minutes to cook a pulse, suppose, then at mountain it may take some 40 minutes also. Time can be double. Why? What is the reason? Because here the water will start boiling much below this 100 degrees centigrade, so that pulse will not get sufficient amount of energy, heat energy. So that is the reason that vapor pressure can be related with temperature and pressure. Now we will see this cavitation. So cavitation is actually the result of this vapor pressure problem. Now what is the problem? So whenever there is a decrease in pressure of the flowing fluid less than vapor pressure, the vapor bubbles, called the cavitation bubbles since they form cavities in the liquid, collapses as they are swept away from the low pressure region, generating highly destructive, extremely high pressure waves. This phenomena, which is common cause for drop in performance and even the erosion of impeller blade, is called cavitation. It is an important consideration in the design of hydraulic turbines and pumps. That is correct. Now you see what happens. Sometimes, suppose a fluid is to be carried like this. So in between there is fluid. There is fluid flowing in this pipe. So suppose fluid is flowing in this manner, right? So this is the reason. This is the reason where here pressure is less than vapor pressure. So here immediately water will start boiling and these kind of bubbles will form. Now this is the high pressure region. This is high pressure region, and because here pressure is low, this is low pressure. Here pressure is low, here pressure is high. So what will happen, these cavities will be carried away by the water in this high energy zone, and once this bubble reaches this high energy zone, they will blast and they will release energy. So that energy is going to impact whatever thing, whatever object comes in their passage, it will be distorted. So I'll show you image of an aluminum object. This is basically cavitation damage on a 16 mm by 23 mm aluminum sample plate. This is aluminum sample test plate tested for 60 meter per second for 2.5 hours. For 2.5 hours, the sample was located at the cavity collapse region downstream of a cavity generator specifically designed to produce high damage potential. So as you can see, all these things are cavity. Now this was deliberately put in that high intensity cavity generator so that we can see the damage done by this cavitation, which occurs due to the problem of vapor pressure. So we need to make sure that whatever your system for fluid flow is, we need to make sure that at any position the pressure of fluid must not fall below the vapor pressure of the fluid for that specific temperature. Okay, so we'll stop here now. Thank you guys.